Hello, this is Mr. White, and this is a podcast on mathematical induction. So, with math induction, we always have 4 steps. The first one being showing that n equals 1 is true. So, we'll start with n equals 1. I always put left-hand side, and if we have the left-hand side with n equals 1, we should have 3 to the 1 minus 1, which is 3 to the 0, which is 1. And then if we go to the right-hand side, 3 to the 1 minus 1, divided by 2, 2 over 2, which equals 1. So that's sort of like saying the first domino of this induction problem has fallen. The next step is to assume true for n equals k. n equals k. So if we have 1 plus 3 plus 9 plus ... plus 3 n minus 1, we are now assuming that this, k minus 1, okay, we're assuming that that is correct. That's our assumption. Okay, and then the third step is to show true for n equals k plus 1. Okay, so we have 1 plus 3 plus 9 plus a bunch of other terms plus 3 to the k minus 1 plus 3 to the k plus 1 minus 1, and that should be, assuming this is true, this should be 3 to the k plus 1 all divided by 2. Okay, so if we simplify this a little bit, this right here is this, or we've assumed it to be. And an important point to remember for mathematical induction is this step right here, step number 2, will always be your substitution piece, always. And then this piece right here is your goal. So you don't ever touch this again. You show this is true. So when we simplify this whole piece right here, it should end up being this. So don't touch it again. Okay, so then this piece right here, like I just said, substitute. We get 3 to the k minus 1 all over 2. Plus, and I'll simplify this right here, we can combine those, 3 to the k. All right, the first thing to do with these math induction problems is to always combine these pieces here. So add the fractions, common denominators. That equals 3 to the k minus 1 plus 2 times 3 to the k all over 2. Like that, and let's see here. Oh, I forgot a minus 1 right here. I was wondering what was going to happen. Okay, so I forgot a minus 1. See the minus 1, the minus 1. We needed that piece. Okay, so 3 to the k plus 2 to the k. That's 3 of them. I've got 1 times 3 to the k, 2 times 3 to the k. So how many 3 to the k's do I have? I have 3 of them. 3 times 3 to the k. And then minus 1 all over 2. So I have 3 to the 1 times 3 to the k. That is 3 to the k plus 1. All minus 1 divided by 2. And there you go. That is your mathematical induction. We just showed that our goal is true. And if you think about it, this it's very difficult to understand why mathematical induction actually works. But just think about it like this. If we assume this piece to be true, and then we show that it's what we expect of this formula, then it has to be true. Because if it wasn't, then there's no way we could have put it into this form. It would have been something completely different. We would have never been able to get it. So that's the math induction part. Okay, so then our fourth and final is just a statement of some sort. There's many ways to write this, but basically it's just since shown I don't want to write it because it's hard to write with these boards, but since shown that n equals 1 is true, and assuming that n equals k is true, it's thus shown that n equals k plus 1 is true by the principle of mathematical induction. So something like that, a statement basically reiterating the mathematical induction. So stay tuned to the next podcast. Thank you very much.